In this series, we're going over every hard advanced math question on the SAT. This is part 3, going over the nonlinear functions questions. In this video, we'll be going over questions 45 through 66. There are 88 questions in the domain advanced math with the skill nonlinear functions and 3 out of 3 difficulty, hence why there are 88 hard advanced math nonlinear functions questions. We've gone through the first 44 in the previous 2 videos in the series. I'll go over another 22 of them in this video, and then the remaining 22 of these specific skill and domain with this difficulty will be in part 4. For every question, you can see up here that there is a unique question ID. If you look in the video description, all of these question IDs will be listed along with the timestamp of the exact minute and second where I start going over that problem, and a brief topic description or topic summary for that problem. So you can search by the topic, or you can search by question IDs if there's a specific problem you want to go over. If you're not finding the question that you're looking for, just look in either the previous 2 parts or in part 4 when that is up. Let's dive right in. It says the function f is defined by f of x equals the quantity x plus 3 times the quantity x plus 1. The graph of f in the xy plane is a parabola. Okay, so it's a quadratic function. Which of the following intervals contains the x-coordinate of the vertex of the graph of f? Okay, so the x-coordinate of the vertex. In this case, it's a positive quadratic. We know that because x times x gives you x squared, so the a value would just be positive 1. If you have a positive a value, then it's going to be a positive quadratic. It looks like a smiley face. So our vertex is going to be that minimum point down there. And we don't actually need to figure out what the vertex is. We don't need to get it into vertex form, which would look like this. A times the quantity x minus h squared plus k, right, is equal to y or is equal to f of x, something like that. Then h comma k would be our vertex. We're just looking for h. You could try to get it like that, and you'd have to complete the square to do so. But the fact that they gave it to us in factored form, which means we have something like this, the factor x plus 3 times x plus 1, will help us find the zeros, and then we know that the axis of symmetry, which is the line that will divide that parabola in half, is going to be halfway between those 2 zeros. And the axis of symmetry will always pass through the vertex for a quadratic, or at least a standard quadratic like this. So that means that if we find the axis of symmetry, the value of that, it will be x equals something, and that will be the x value of the vertex, so what we're looking for. So we basically just need to figure out what the 2 zeros are, and it's when would this be equal to 0. So f of x equals 0 when either x plus 3 is equal to 0 or when x plus 1 is equal to 0. And we could say x plus 3 is equal to 0 when x is equal to negative 3. Right? Negative 3 plus 3 is 0. And x plus 1 is equal to 0 when x is equal to negative 1. Negative 1 plus 1 is 0. So those are our 2 zeros, negative 3 and negative 1. And then if you want to do the halfway point between those two, negative 3, negative 1, that would be at x is equal to negative 2. So our axis of symmetry is x is equal to negative 2, and that means that the vertex will pass through that axis of symmetry. So the vertex has an x-coordinate of negative 2. Now, if we needed to find the y-coordinate, we would need to plug that negative 2 back into the function. You have to do negative 2 plus 3 times the quantity negative 2 plus 1. Figure out what that is. We don't need to do that here. Which of the following intervals contains the x-coordinate? So we just need to figure out which interval contains x equals negative 2. So negative 4 is less than x is less than negative 3. No, negative 2 would be to the right of that on the number line, so that wouldn't include it. Negative 3 is less than x is less than 1. Yes, negative 2 is between negative 3 and 1. And then 1 is less than x less than 3. Nope. 3 is less than x is less than 4. No. So that would be B. The function f is defined by f of x equals a to the x power plus b. So we have an exponential function shifted up, translated up by b, where a and b are constants, and it says a is greater than 0. So a is a positive number. That means it's not going to be an exponential function that's alternating based on if a is raised to an even or an odd power. Right? If you raise a negative to an even power, it becomes positive. If you raise it to an odd power, it stays negative. Doesn't matter here because a is greater than 0. In the xy plane, the graph of y equals f of x has a y-intercept at 0, negative 25 and passes through the point 2, 23. What is the value of a plus b? First, we can use this y-intercept by plugging in 0 for x and negative 25 for the value of the function. So for f of x, we get negative 25 is equal to a to the 0 power plus b. And anything to the 0 power is 1. So whatever a is, doesn't even matter that it's a positive in this case. Even if it was negative, it'd be the same thing. That gives us negative 25 is equal to 1 plus b. Now to get b alone, you just subtract 1 from both sides. It gives us that b is equal to negative 26. All right, so now that we have b, we can rewrite this function. We have f of x is equal to a to the x power. We still don't know what a is, but we do know what b is now. Plus b means minus 26 because it's plus a negative 26. All right, so this is our function. We need to solve for the a, and we can now solve for the a using this point, the 2 comma 23. So when x is equal to 2, we'll say a to the 2 power instead of a to the x power minus 26. That gives us an output, an f of x value of 23. So 23 equals a squared minus 26. Now we can add 26 to both sides to get the a term alone, or the a squared term, I guess we'd say. And that means that a squared is equal to 23 plus 26 is 49. So a squared equals 49. And in general, if you had a squared equals 49, you'd have two different solutions, right? Because a could be positive or negative 7. To get rid of a squared, you're taking have to do plus or minus the square root of both sides, which gives us a is equal to plus or minus 7. But they told us a is greater than 0, so if our two options are a is equal to 7, a equals negative 7, we can cross out negative 7, because that doesn't follow this rule of a being greater than 7. So a equals 7. Now, if we rewrote the entire function, it would be f of x is equal to 7 to the x power. So 7 is like our growth factor here. It's the base of the power here, plus b, so we're shifting down 26. Right, and I think all they're asking for is what is a plus b. So we know a is 7, b is negative 26, so we would do 7 plus negative 26, which it's going to still be negative, but adding 7 to the negative 26 makes it less negative, so it'll be negative 19. Right? Negative 19 will be our answer there. Always take the extra time. What were they asking for? I, for a second, thought that they just were asking what is a, because that's the last thing that you would solve for. But just take the extra second or two to check what exactly do they want. You don't want to do all of the work and then mess it up just because you didn't know what they were looking for specifically. A landscaper is designing a rectangular garden. The length of the garden is to be 5 feet longer than the width. If the area of the garden will be 104 square feet, what will be the length in feet of the garden? We could draw out our rectangle. It's a quadrilateral with 4 right angles. The opposite sides are going to be equal length. So we've got these two lengths, length and length, and then you've got the widths, which the length is 5 feet longer than the width. So that means the width is 5 feet shorter than the length. So instead of a W, we could just write L minus 5 on these sides. L minus 5. All right, the area, I didn't have to write them all out. I was thinking it was perimeter. But the area of a rectangle is just length times width. In this case, our width is the L minus 5. So we would just plug that in. We get the area is equal to the length, L, times the width, which is L minus 5. And I'm going to put that L minus 5 in parentheses, so I know I'm multiplying the entire width, the L and the minus 5, by the length. All right, so we get L times the quantity L minus 5. And now I have to distribute this L to both terms. L times L will give me L squared. L times minus 5 will be minus 5L. So the area, which we said is equal to 104, and I'll plug that 104 in, is equal to the length squared minus 5L. Okay, what will be the length in feet of the garden? All right, so what we can do now is set it up as a quadratic equal to 0 by subtracting 104 from both sides. And then we'll have 104 minus 104 is 0 over here. We get 0 is equal to the length squared minus 5 times the length minus 104. All right, so now we could factor this and solve for our zeros, and then whichever one is, and it looks like one of them will be negative, one of them will be positive. You can't have a negative length, so we would keep our positive answer. And I guess I'll show how to do that. But if you got to this point, you set up your equation, you know you set it up correctly, this is probably where you should turn to Desmos. So just type this exact thing. You could even type it in as y equals that, or if they have f of x equals, I think you usually have to write it as y equals. And then you change your l's to x's and just see where the two zeros are. So where does it cross that x-axis? And the positive value for the 0 there would be your answer here. Okay, so that's how you would do that. I'll show how to do that in a minute. But first, just in case, I don't know, you don't want to use Desmos, or you don't know how to use Desmos correctly, or you just want to check it, you could factor it just by hand. And we would go, what times what is L squared? Well, L times L is L squared. For the OI term, so like the outside times outside, inside times inside, you get a sum of negative 5L, and you get a product for your L term of negative 104. So if they multiply to make a negative, then one of them is negative, one of them is positive. So we do L minus something and L plus something, and the two numbers will be 5 apart. So for 104, let's see, the factors of 104, we would have 2 times 52. 52 is 2 times 26, which means it's 2 times 13. All right, so we get 2 times 2 times 2, that's 8 times 13, and 8 and 13 are 5 apart. All right, so 8 and 13 will be the things that will add up to negative 5 if one's positive, one's negative. We want the 13 to be the negative because we have more negatives than positives. That's why the sum is negative 5. So it'll be L minus 13 and L plus 8, right? So if you FOILed that out, it would give you the same thing, L squared minus 5L minus 104. All right, so 0 is equal to that, and then if you're multiplying two numbers and your product is 0, one of the numbers you multiply is equal to 0. So either L minus 13 is 0 or L plus 8 is equal to 0. L minus 13 is 0 when L is equal to positive 13. And L plus 8 is equal to 0 when L is equal to negative 8. Right? Negative 8 plus 8 is 0. 13 minus 13 is 0. All right, so those would be your two zeros. Again, this is for a length of a rectangle. You can't have a negative length. So we're going to reject the negative answer here. And that means that the only possible length is 13. So 13 would be our answer. Now, I will show you how to check it in just a second on Desmos. But the other way you could check it is just figure out if it's actually true. So if the length was 13, L is equal to 13, then that would mean that L minus 5, so 13 minus 5 would be equal to 8. 8 times 13 is in fact equal to 104. That's what we just did over here. So that does add up. Those two things are 5 apart, the length and the width. The length is the longer of the two, as it's specified in the problem. And generally, that's what you would assume. Like length generally means it's the longer of the two of a rectangle if there's a length and a width. Don't necessarily assume that's true, but here they specifically said the length is to be 5 feet longer than the width. All right, so that would be how you do that completely algebraically. How I would do it with Desmos, I would first still set it up the same way and probably multiply it out. I guess you could actually even write it out without like distributing. So you could just subtract 104 from both sides. So you have a 0 alone, then you set that equal to y. You'd say y is equal to, instead of L, we'll write x. So x times the quantity x minus 5 minus 104, and it would still work. I mean, I would probably just do this, but again, that's just another opportunity for you to mess it up. So it is fine to write it not simplified, or not fully simplified at least. Again, you could write it either way. I'm just going to write it the normal way first. So x squared minus 5x. Again, I'm just putting x's in place of the l's, put y in place of the 0. And then you're just figuring out when y is equal to 0. And then we had minus 104. And just like we did algebraically, we got 13 as our positive 0. So that'd be your answer. The other one is negative 8, which we can reject because you can't have a negative length. And just to show that you would get the same thing, if you left it as x times the quantity x minus 5 minus 104, and I didn't even write equals y, they just assume it's equal to y unless you say otherwise. It is the same thing, right? 13 and negative 8. All right, so that just shows you don't have to distribute or simplify something first before you type it into Desmos. It's kind of nice. It's kind of like a little cheat code there. And I guess it does prevent the opportunity of, if you are someone who tends to mess up when you're doing distributive property or simplifying, then you don't have to worry about that so much. I guess we could even go like this. You could set it so x times the quantity x minus 5 is equal to 104. So without subtracting the 104 from both sides, and then you just get the two answers, 13 and negative 8. So either of those will work, or so any of those three would work. You could do that right from the get-go. I tend to like to do it algebraically if it's doable in a short amount of time, and then you can use Desmos to check. But whatever you prefer, both systems will get you the right answer and hopefully give you a lot of confidence that you got it right. All right, here we have this function p of t is equal to 290 times the quantity 1.04 to the power of 4/6 times t. The function p models the population in thousands of a certain city t years after 2005. So when t is equal to 0, that's the population value in 2005. According to the model, the population is predicted to increase by n% every 18 months. What is the value of n? All right, so t was years, and now they're doing it in months. So 18 months is 1.5 years. Think 1 year is 12 months, so it's 12 months plus half of 12 months, just 6 months to get you 18 months. So whenever t goes up by 1.5, which if you write it as a fraction would be 3 halves, which is equal to, here they have 4/6, which it's equal to 6/4, so the reciprocal of what you're multiplying t by. So this is actually the second time that we've seen a problem like this, where they had it raised to an exponent that was like a fraction times a variable exponent, but because of the way the problem was worded, it actually canceled out. So you didn't really have to worry about the fraction. I mean, the fraction, you do have to worry about it to make sure that it's right, but it doesn't really affect the actual math once you're doing it. So I'll show you what I mean. So we want to figure out when it goes up by 18 months. One way you could get this is like if you're trying to figure out what 18 months is in years, you could just divide it by 12. So 18 over 12 is equal to the change in t, so how much t is going up. So you could do 18 twelfths, and if you simplify that, I mean, again, I don't know why I left it as 4/6 instead of 2/3, but this would simplify to 3 halves, or again, you could write 6/4 if you want. So for figuring it out, that would mean it's going up 3 halves times 4/6. 3's would cancel, the 4 and 2 would cancel, we get 2 over 2, that's 1. So basically, you're just increasing the exponent by 1, which for an exponential function, you've got your growth factor here is 1.04, and then anytime that the actual full exponent, not just the t part, but when this entire exponent goes up by 1, that means you're multiplying by 1.04 one more time. Right? Because think 1.04 to the 0 power is equal to 1 when you raise it to the first power. So raising that from a 0 exponent to a 1 as the exponent, then you multiply by 104 one time. If you did 1 times 1.04 squared, then you're multiplying by 1.04 2 times. So it's one additional time after the 1.04 to the first power. All right. So again, they said according to the model, the population is predicted to increase by n% every 18 months. Well, it's increasing by 4%. You're multiplying it by 104%, 1.04, but that means you keep the 100% of what you had, and then you go up 4% from there. Right, so it's going up 4%, and we don't have to write 0.04, right? That would be 4% as a decimal, because it says n%. We just want the value of n, so what percent? That's 4%, so it'd just be C. For the function f of 0 is equal to 86. And for each increase in x by 1, the value of f of x decreases by 80%. What is the value of f of 2? For the function f of 0 equals 86. So that's your initial value when x is equal to 0, we get an output of 86. And for each increase in x by 1, so every time x goes up by 1, the value of x, or the value of f of x, the output, decreases by 80%. So you had 100% of whatever it was, 86 at the beginning. You had 100% of that 86, and then when you go up by 1, like your x value goes up 1, then you lose 80% of that. So you lose 80% of 100%, which means you were multiplying it by 20%, or 0.2. This is like I guess it's our decay factor, but it's the growth factor spot of, I guess this is going to be an exponential function. Right? So you start with 86, that's your principal value, and then you're multiplying it by 0.2 to the x power. So every time x goes up by 1, you multiply by 0.2 one more time. What is the value of f of 2? All right, well, we've got our function now. F of x is equal to this. And you can even test that out. F of 0 would be 86 times 0.2 to the 0. Anything to the 0 power is 1, so that's 86 times 1 would give you 86. And then when you increase the x by 1, so give you f of 1, it'd be 86 times 0.2 to the 1. So you're multiplying it by 0.2, which loses 80%. Okay, so this is the correct function here. And now we just plug in the 2 for x. So we get f of 2 is equal to 86 times 0.2 to the second power, 0.2 squared. I'll keep it in parentheses just so you know, but exponents do come before multiplication anyway. And that would give us 86 times 0.04. I guess this is where you could just use your calculator. Do I not have mine? I think I brought it upstairs. So, I mean, that's 4 100ths, right? So or if you want to do it as a fraction, you could say you're multiplying by 1/5 twice. It's 1/5 times 1/5. And 86 doesn't have any 5s in it. So it'd just be, as a fraction, 86 over 25. That'd be an acceptable answer. Or I guess if you want to make it into a decimal, then you would just you could get it into hundredths. So that'd be 86 over 25 times 4 over 4. Now again, don't do this if you have a calculator. It's a waste of time, unless you have a lot of time and you just want to kind of, I guess, entertain yourself. But let's see, that'd be 24 plus 320. So that'd be 344 over 100. So you'd write that as 3.44. Right? So 3.44 is a decimal. I'll just show that you can do that also in Desmos. Y is equal to 86 times 0.2 to the x power. Here's your exponential decay. You can see when x was equal to 0, it is in fact 86 like we wanted. And then if we zoom in, when x is equal to 1, it goes down to 17.2, which let's see, 86 times, and just to show, 1 minus 0.8, so losing 80% does give you 17.2, so that checks out. And this is not our answer. They wanted when x is equal to 2, so we'd say x equals 2. So where do those intersect? It would be at 2, 3.44, so our output is 3.44. After x goes up to 2, then your output is 3.44, which again is what we got here. It's equivalent to 86/25. Either of these answers are acceptable. Just if you have a fraction, make sure it's fully simplified. This is. If you have a decimal, then you can just enter it in like that. Here we have m is equal to 1800 times 1.02 to the t power. So another exponential function. Here are principal values. So the initial value is 1800. Our growth factor is 1.02, which means our growth rate, how much we're actually going up, is 2%. Because you keep the 100% you have, that's the 1, and then it's plus r, the growth rate, which is 0.02 or 2%. All right, so anytime t goes up by 1, you're multiplying it by 1.02, you're growing 2%. The equation above models the number of members m of a gym t years after, so t is our input here, it's the exponent there, after the gym opens. Of the following, which equation models the number of members of the gym q quarter years after this gym opens? Okay, so essentially, if you're multiplying it by 1.02 every year, then for every quarter year, you're not multiplying it by 1.02. It's not growing 2% every quarter. It would take 4 quarters to do that. So essentially what we need to do is, divide q by 4. So that when q goes up by 4, that's the same as it going up 1 year. So that would just be option A. And, just think of it logically. Okay, so if you went from 0 years to 1 year, then t would go from 0 to 1. From 0 years to 1 year, how many quarters pass? That would be 4 quarters. So it'd go up by 4. So you make the q go from 0 to 4. 0 fourths is the same as just 0. And then it would go up to 4 fourths. 4 fourths is equal to 1. So it's the same. Otherwise, you have the 1800 times 1.02, and it would be to the first power. And then if it goes up to t is equal to 2, well, that's 8 quarters, right? 4 quarters per year times 2 years. So 8 fourths, that's also raising it to the second power. All right. So hopefully you can get to a point where you can see these and immediately know what you're supposed to be doing with them. But when in doubt, just take the extra couple of seconds to check. Just plug in some numbers. Even if you want to do it on Desmos, you could see if they are, in fact, the same functions. And just, make sure that you're accounting for the fact if t goes up by this amount, what would that mean q is going up by? It would be going up at 4 times that rate. And just looking at this one, you're multiplying it by 4. No, because there's more quarters pass in a year, right? 4 quarters pass per year. So that'd mean that every year that passes, this would be going up by 16. That's not good. Same thing here. Here they just changed the rate. That doesn't necessarily work because you have the compounding growth then. And also, I think then you wouldn't be raising it to the 4th power. It would just be q. So this one, if you took out the 4, it'd be close to correct, but A would be the correct thing. Because then you're accounting for the fact, right, if you just raised it by 0.5% every quarter, then even though 0.5 times 4 is equal to 2%, you're still actually going to be growing more this way because it's 0.5% of a higher amount each quarter. So you get 0.5% of that additional 0.5% as well as the 0.5% that you want. And then this one, I don't know what they're doing here. I think they raised it times 1.02 to the 4th power is probably what this is. Does that number look about right? But that's not something that you should be doing, no. All right, so this would be just A. Don't overthink it. The functions f and g, so we've got f down here is f of x equals 33 times the quantity 0.44 to the x plus 3 power. And g is here, it's this function 2. G of x equals 33 times 0.16 times 0.4 to the x minus 2 power. And it says they're both defined by the given equation, so the equations we just underlined, where x is greater than or equal to 0. So we know x is not negative, so we don't have to worry about negative values going in for that and how that would affect it. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines where x is greater than or equal to 0? Which of the following equations, so either f of x or g of x or both or neither, displays as a constant or coefficient, so constant or coefficient, any of the numbers on here, so 33, the 0.4, the 33, the 0.16, the 0.4, the maximum value, oh, that's why the x is greater than 0 part matters, because if it's decay, technically, if you go to negative values, then since it was decaying before that, it's continuing to decay, it would go up to infinity. Maximum value of the function it defines where x is greater than or equal to 0. Okay, well, I think what's going to affect this is the fact that it's x plus 3 and x minus 2, which does mean that you shift it over, right? You're shifting it, in this case, the plus 3 means you're shifting it to the left by 3. So, right, it's an exponential decay function. Neither of them has a negative growth factor or anything like that, or a negative growth factor or a negative principal. So they are going to be going down, right? Basically approaching 0, y equals 0. But normally you would have it cross the y-axis at the principal value. So this one would be 33, this one would be 33 times 0.16, because this part would get canceled out, right? It'd be 0.4 to the 0 power, which is 1, so you wouldn't have to worry about that part, so you would just have this part up front. But because it's x plus 3 or x minus 2, this is only equal to 0 when x is equal to negative 3. This is equal to 0 when x equals 2. So they're trying to trick you with that, where people will go, oh, no, it's not actually the minimum value. But with a decay function, like we said, like the reason that they are specifying that x is greater than or equal to 0 is otherwise it just keeps going up infinitely when you move to the left, right? Because you raise it to 0.4 to like the negative 10th power, right? A decimal that's less than 1, when you raise it to a negative power, right? That means it's 1 over this fraction. So 1 over 0.4 to the 10th power. So that will actually make it, even this like the 0.4 to the 10th power gets really small, that's in the denominator, so it make it a bigger and bigger number. So it goes up and approaches infinity eventually when it's 0.4 to the negative infinity power. So even if you shift it, the fact that we have the domain restricting it so that it can't go to a value where x is less than 0, then the highest point for a decay function is going to be the furthest point to the left, right? A decay function where, again, you have a principal value. So in this case, that means that when x is equal to 0, that will be the minimum, right? So it would be 33 times 0.4 to the x plus 3 would be to the 0 plus 3 when x is 0. So that's to the 3rd power. But here's the thing, is that's not actually your maximum value. So the point there when x is equal to 0 would be the point where it's at its maximum. But instead of just being 33 times 0.4 to the 0, which is 33 times 1, which gives you 33, it's 33 times 0.4 cubed, which is smaller than 33. Right? You're multiplying it by this decay factor that's making it smaller. So for 1, it's not going to be the case. And then for 2, well, let's check. So 2, they have this times 0.16. I think it won't be the case, but 2, I don't know. I was wondering why they put this 0.16, but maybe they put a value that will make it work. So let's check it out. So we have 33 times 0.16, and if x is equal to 0, which is going to be your maximum point for that, right? Because it doesn't go anything further to the left of that, and it's going up and up and up as you move to the left. So this will be your maximum point when x equals 0. And that means that g of 0 is equal to 33 times 0.16 times 0.4 to the x minus 2. We said x is equal to 0, so to the 0 minus 2 power, which is to the negative 2. All right, so we get 33 times 0.16 to the times 0.4, which let's write that as 2 fifths. Right? It's 4/10, which is 2 fifths. 2 fifths to the negative 2 power. That's 0 to the negative 2. And for a fraction, if you raise it to a negative power, then you would have to flip that fraction, so to do the reciprocal to that power. So this is the same as 5/2 squared. 5 squared over 2 squared. So we have 33 times 0.16 times 5 squared times 2 squared, which gives us 25 over 4. Now, this will matter because 0.16, if we write that as a fraction, you could say it's 16 over 100, but both of those have 4 as a factor. So we would divide the top and the bottom by 4. That gives you 4 over 25. So we see that this is now the reciprocal. When x is equal to 0, you get 0.4 to the negative 2 power, which is equal to the reciprocal of 0.16. And now when you multiply these out, 4 divided by 4 is 1, 25 divided by 25 is 1. You're just left with 33 times 1, right? This is equal to 1 over 1. So 33 times 1 over 1, which equals 33. So the maximum value for g of x is, in fact, 33, which is a coefficient here. Or I guess you could say it's a constant here. It's that 33. So 1 is, they don't have the value on there, because you would need 33 times 0.4 cubed, which is less than 33, and it's not equal to 0.4. So no, it's not 1. It's also not c, because that is 1 and 2. But it does have 2, because 2 has the maximum value for this function. When the domain says x has to be greater than or equal to 0, then it would be 2. Now, if they didn't have this part, the x is greater than or equal to 0, then both of these functions, the maximum value would be infinity, or like it approaches infinity, because it's a decay function, and as you go more and more negative with the exponent, it would go up and up. All right, but in this case, the answer is 2. All right, so this was an interesting problem. Hopefully I didn't lose you. If this one was confusing, make sure to put that in the comments. Maybe I can explain it better either in the comments or potentially in like a short follow-up video. But ultimately what we're getting at here is it doesn't necessarily matter just that you shifted it, right? Shifting it still means that because the domain is limited at x is greater than or equal to 0, then when x is equal to 0, that's going to be your maximum value for that function with that domain. But you have to make sure, how does it affect it? So like the principal value only works when you're raising it to the x power. So if you're raising it to the x plus something or x minus something, that shifts it, and it will affect the maximum value. Just in this case, for g of x, the 0.16 and the 0.4 to the negative 2 power canceled out. I guess let me show probably an easier way to do this. I mean, I know it sounds like this took a long time, but that's because I was trying to explain it as you're going. But if you know what you're doing, you could probably figure this one out really quickly. And you wouldn't have to explain every step of the reasoning. But the other thing you could do is just type these into Desmos and see, is the maximum value any of those numbers there? All right, so we go y is equal to 33 times, what was it, 0.4, 0.4 to the x plus 3 power. And you can see the maximum value here. Ooh, I just did plus 3. It should be, make sure the plus 3 is part of the exponent there. X plus 3 power like that. And it still didn't do it. X plus, what? Why is it doing this? All right, I'm going to put the exponent in parentheses. To the x plus 3 power. All right, just be really careful of that. I guess that's one downside of doing it with Desmos, is you might not realize that it had that error. I might not have realized that if I hadn't done the problem already. So you can see the maximum value there is 2.112. That's not equal to 0.4. It's not equal to 33. So it's none of those values on there. All right, and then the other one, we had y equals, and I know it was f of x equals g of x equals, but you just put the y in place of that. And it was 33 times 0.16 times 0.4 to the power of parentheses x minus 2. Don't forget the parentheses again. I mean, maybe you can get a way to make it type it in there, but here we can see our maximum value. So again, you have to have x is greater than or equal to 0. So read that carefully before you go over to Desmos. Our maximum value is 33, which is one of the values here on here. Right? We had 33 times 0.16, so 33 is one of the numbers. I guess you would consider that. I mean, you could kind of consider it a constant or a coefficient. That's probably why they put them both in, because you're multiplying it by something that has the x out front, but it's technically the a value of this thing, so it's more a constant. All right, so the second function, g of x, did work. f of x, it was not the case. So you could do Desmos, and it probably will be faster, but there was some room for error there, especially when it came to typing in these exponents that have like arithmetic inside of them. So x plus 3 or x minus 2. It seems like Desmos defaults to thinking that you're doing plus 3 after the power, where you want it to be part of the exponent. The function f is defined by f of x is equal to a times x squared plus b times x plus c, where a, b, and c are constants. The graph of y equals f of x in the xy plane passes through the points 7, 0 and -3, 0. So those are your two zeros, right? When the two values of x, that will give you an output of 0. If you got into factored form, it would be x minus 7, or the quantity x minus 7 times the quantity x plus 3. If a is an integer greater than 1, which of the following could be the value of a plus b? Well, what we can do here is right away, I'm thinking it's going to be something that has to do with the axis of symmetry. So we know the axis of symmetry will pass through the vertex, and it will be halfway between the two zeros, which they gave us those two zeros, and it's always going to be equal to negative b over 2a. Now, if you have trouble remembering like that's negative b over 2a, then you can just use the quadratic formula song. So x equals negative b plus or minus squared root b squared minus 4ac all over 2a. And just remember that you've got your axis of symmetry, the negative b over 2a, and then what you're adding or subtracting is to get the zeros, which would be either plus square root of b squared minus 4ac over 2a, or minus square root of b squared over 4 or minus 4ac over 2a. All right, so this negative b over 2a, right, it's in the song for the quadratic formula. It's also, if you just do that part, that is going to be your axis of symmetry formula. All right, so x equals negative b over 2a is our axis of symmetry. If we want to find the axis of symmetry, then we could just figure out what's the middle of 7 and -3. Draw our axes. We had -3 here. 1, 2, 3, 4, 5, 6, 7 right there. So 7, 0, -3, 0. Now you could think, what do you have to add to -3 to get to 7? That would be, you have to add 10. So add half of that, which would be adding 5. 1, 2, 3, 4, 5 up to 2, 0. Or you could do 7 plus -3 divided by 2. It's the average of the two values. 7 plus -3 is 4. 4 over 2 is equal to 2. All right, so either way, you're getting that 2 is the value of the axis of symmetry. So that means that 2 is equal to negative b over 2a. Now, if we want to get them separate, and it said a is an integer greater than 1, so we don't have to worry about a being 0 and you're dividing by a negative here. Just multiply both sides by 2a. That gives us that 4a is equal to negative b. So, I mean, we could even make that b is equal to negative 4a. Right, so now we have b in terms of a. If we want to write out a plus b, you'd get a plus, instead of b, we're doing negative 4a, an equivalent value. So a plus negative 4a would give us negative 3a. All right, so we want to figure out which could be the value of negative 3a. And they said a is greater than 1. So to get either 5 or 4, you'd have to multiply by a negative. Negative 3 times another negative number. That'd give you a positive. But again, they said it's greater than 1. Negative numbers are not greater than 1. So we can immediately eliminate those. And then to get this negative 3a to be equal to negative 3, a would have to be equal to 1 exactly. 1 is not greater than 1. 1 is equal to 1. So we know it's not b. All right, negative 6. Let's see, to check that, if you want to check if that works, you say, okay, well, what would a have to be to make this negative 3a equal to negative 6? A would have to be 2. So our a value would be 2. You can figure out what the b is, which is multiplying it by negative 4. B would have to be negative 8. But what I'm thinking is, if we write it out using these zeros in factored form, you get y equals a times, and it would be x minus 7 is when this is equal to 0, right? When x equals 7, 7 minus 7 is 0. And then for this negative 3 comes 0, that would be x plus 3, because negative 3 plus 3 is equal to 0. So we write it like that, and then we just plug in our a value, which is 2. So you can do it like that. And now if we FOIL this out, we get, I could even write 2x minus 14 like that. So 2x minus 14 times the quantity x plus 3. That gives me 2x times x is 2x squared. 2x times 3 would be 6x. And then we have minus 14x. So 6x minus 14x is negative 8x. Like we said, is what b should be, negative 4 times 2. And then negative 14 times 3 would give us negative 42. So y equals 2x squared minus 8x minus 42. You could plug that into Desmos. right? And it does pass through those two zeros we want, -3 and 7. Right? And it passed the rule, a is an integer greater than 1. So a is equal to 2. Okay, so that's just a way to check your answer after you've done this. But the main thing we're doing here is using your axis of symmetry to relate the a and the b, and then just figuring out logically which of those could work if a is an integer greater than 1. Here's one strategy that I'm going to tell you. Now, I just showed you how to do this one, so hopefully if you get a problem that's just like this, you can now do it, or hopefully you could have done it anyway. But anytime they say which of the following could be the value of something, a plus b, or what could be the value of a plus b plus c, or x, or something like that, generally, that means that it's going to be, instead of there being one answer, it's either a range of values or more likely there's some inequality that like restricts the domain. So it's more like an array of values, especially if it's quadratics, or maybe if they give you some stipulation like this, right? A is greater than 1. Okay. So the integer could have also been a thing, right? Like they could have given -7 as an answer there, which would work if a is greater than 1, but not as an integer, right? It wouldn't be an integer there. But anyway, generally what I'm noticing is when they have one that's like which of the following could be the value, it's probably going to be either A or D, or assuming that they listed them in either increasing or decreasing order. I don't know if they scramble them on your test, but it's probably either going to be the smallest or the biggest value, because it's probably something where, right, if A is greater than 1, then this thing has to be either more negative than that, or either has to be the highest absolute value that's negative, or it has to be the highest absolute value that's positive. You'd have to do the math to be entirely sure, but say you got to this problem, you only had 20 seconds left, you don't think you're going to be able to solve it, then you could say, okay, which of the following could be the value? It's probably not going to be one of the middle values. You could cross off B and C, and then you just doubled your chances of guessing it right. You went from guessing it right 1 out of 4 of the time, if you're doing it completely randomly, to 50-50, to guessing it half the time. Right? So that's just a little trick. Now, hopefully you also understand how to do it. What the algebra was here, how to check it on Desmos afterwards. I know some people will also just go straight to Desmos and use those moving slider things. I don't necessarily think that's faster than just doing it algebraically, as long as you know what you're doing. But also keep in mind that there are tricks like this. If it's which of the following could be the value, then on the SAT, you probably can eliminate the middle values. Square P has a side length of x inches. Okay, so we have a square. That means all the sides are the same. All the angles inside are 90 degrees, the right angles, and it's x by x. This is square P. Square Q has a perimeter of 176 inches. All right, so 176 is the entire perimeter when you add up all 4 sides. So if we divide that by 4, well, it's like 160 plus 16. So divide by 4, that's 40 plus 4. So each side would be 44 for this is square Q. Now, I don't know if that's bigger or smaller than P, or it could even be the same. But it says, 176 inches greater than the perimeter of P. Interesting. Okay, so whatever the perimeter of P is, that would be 4x. So 4x is the perimeter of this, perimeter of P. And that means that you're adding 176, you're adding 4 times 44. So actually this would be x plus 44 on all the side lengths there. All right, so probably read it before you start drawing your diagram fully. Don't do what I just did there, where you interrupt yourself in the middle of the sentence. But I guess even if you do, you can ultimately figure it out, just like we did there. The function f gives the area of square Q in square inches. Which of the following defines f? Okay, well, like we said, the lengths of the sides of Q are x plus 44, right? Because you're adding 44 4 times to the perimeter to get that 176. You can even check that if you want. 4 times x plus 44 gives you 4x plus 44 times 4 is 176. So this would be the perimeter of Q. The perimeter of P, as we said, is just 4x. So this is 176 more. Right, that checks out. All right, so we want to find the area of square Q. And the area of a square is just side times side, or side squared. So this means the area of Q is equal to x plus 44 squared, or x plus 44 times x plus 44. The same thing. Oh, they wrote it just as squared. Right? I thought they were going to have me FOIL it out, but I guess that's all you've got to do. Which of the following defines f? All right, this one, I don't see why this is in the hard section. I guess some people might get thrown off a little bit by the perimeter stuff, but this definitely at least could have been the medium section, I think. But yeah, so they've plus 176. No, I guess, yeah, they're hoping people will read it wrong, where they think the length of the sides is 176 greater, but no. And then This one looks like, what, they start foiling it out? This one, I'm not sure what they're trying to do here. They put 176 as a coefficient of the x inside of the, okay, that didn't make any sense. Neither does this. All right, so A is clearly the answer there. The surface area of a cube is 6 times parentheses a over 4 and parentheses squared, where a is a positive constant. Which of the following gives the perimeter of one face of the cube? Okay, so perimeter of one face of the cube. So just basically the perimeter of one square of it. All right, so the surface area of a cube, I mean, there's 6 faces on a cube, and cube means that all the sides, like the length, the width, and the height are all the same. So you can actually write the surface area of a cube as 6 times the side squared. So 6 times the length of one side squared. Side, side, side. These problems, the last one and this one, are kind of more geometry questions with very basic algebra, I would say, but I guess, it has to do with nonlinear functions. So in this case, that means, right, if we have 6 times the quantity a over 4 squared, the a over 4 is in place of the s, which means that the side length of the square is equal to a over 4. Now, which of the following gives the perimeter of one face of the cube? Well, one face is just a square, so the perimeter of that is just 4 of those sides, right? You have side, a side, a side, and a side. So 4 times the side is equal to 4 times the side length we said is a over 4, so 4 times a over 4. 4 divided by 4 is 1, so let's cancel out. We just get 4s, or the perimeter of one side, is equal to a. So that'd be b. So this one, yeah, again, I would really put this more in the geometry section, but I don't know, it's a fun problem. If you get one like this, I understand why this one's in hard, I guess, because it could throw some people off if they're trying to just plug it into some equation and chug it out. You have to actually understand where the surface area is coming from, understand what they're talking about of the perimeter of one face. But, if you know what you're doing in this problem, you could do it in like 20 seconds or less. All right, the graph of the given equation, and the given equation is y equals 576 to the power of parentheses 2x plus 2. So the graph of that given equation in the xy plane has a y-intercept of r comma s. Which of the following equivalent equations displays the value of s as a constant, a coefficient, or the base? All right, well, this one is m sup, so I don't actually think we can solve this one. I guess we could figure out what s is, and then, if you had the options, you could figure out which of those had that s as either a constant, a coefficient, or a base. And if it happens to be either the 1 over 24 or 1 over 576, then we would know it's either C or D. But if not, then we can't actually solve this one, but we would have done all of the legwork of it, the hard parts. All right, so the graph of this, and what do they say, though? That's the y-intercept. So y-intercept is when x is equal to 0. Okay, so we just plug that in, 576 to the, instead of 2x plus 2, we'll do 2 times 0 plus 2. Right, because again, y-intercept is when x is equal to 0. So y equals that, and that means r is equal to 0, right? Because r is the x value of the y-intercept. Well, again, the x value of a y-intercept is where it crosses the y-axis. So by definition, the x value is 0, right? It can't be to the left, can't be to the right. You're only moving up and down to stay on the y-axis. So 2 times 0 is 0. 0 plus 2, we get 576 squared. So y equals 576 squared. Which of them displays the value of s as a constant, a coefficient, or a base? So I guess whichever one of them has 576 squared, and I'm not even going to multiply that out because, again, they don't have it as an option. But I assume that's not C or D then. I don't know if one of these would have that written out. But yeah, we don't have the m sups. We can't answer this one. But again, this is what s is equal to. R comma s is 0 comma 576 squared. Now again, if they actually had the numbers written out, I would check what that is, but we don't need to. It's another one that I would probably just do on Desmos. Multiplying 576 out by hand would be kind of a waste of time. Although, not something I'd be above, but if you're on the test, don't do that. Here we have the function h is defined by h of x is equal to a to the x power plus b, where a and b are positive constants. So they're both positive constants. The graph of y equals h of x in the xy plane passes through the points 0, 10. So this is the y-intercept, right, when x is equal to 0. And the point -2, 325 over 36. Okay, that's kind of ugly. What is the value of AB? Okay, well, we've had a couple like this. You just start with plugging in the 0 for x and the 10 for h of x, or for your output. You get 10 is equal to a to the 0 power, 0 is what we plugged in there, plus b. Now, the a to the 0 power, anything to the 0 power is 1. So this gives us that 10 is equal to 1 plus b. And then to get b alone, you just subtract 1 from both sides. You get b is equal to 9. All right, so our b value is 9. We could rewrite this as h of x equals a to the x plus 9. And now that we only have one constant, just the a, there's no b left because the b is replaced with the 9. Now we can plug in this -2, 325 over 36. So the output is the y value, that's 325 over 36. So we'll plug that in over here. And that's equal to a to the, now x is going to be -2, so a to the -2 power plus 9. So anything to the negative, if you have a negative power, you would flip it to the other side of the fraction. You know, there's no fraction here, but this is the same as a over 1. So it become 1 over a squared. So we get 1 over a squared, and then I'm going to subtract 9 from both sides to get the a term alone. And that gives us 325 over 36 minus 9 times 36 over 36, like that. Minus, I'll do 9 times 36 over 36. Right, you're subtracting 9. I'm giving it a common denominator there. And that'd be, let's see, 9 times 30 would be 270. 9 times 6 would be 54. So 270 plus 54 would be 324. So we get 324 over 36 being subtracted from 325 over 36. And that's equal to 1 over a squared. Well, since they have a common denominator, you could just combine the numerators there. So 325 minus 324, which is 1. We get 1 over 36 is equal to 1 over a squared, which tells us that a squared is equal to 36, right? 1 over 36 equals 1 over a squared. Do the same thing. So 36 equals a squared, which would mean that a, so to get a alone, you can't just do the square root. You'd have to do plus or minus the square root, both sides. So technically the opposite of squared. Or you could just think what squared equals 36. It could be either positive 6 or negative 6. So we get a is equal to plus or minus 6. But I think they had the stipulation a and b are both positive constants. So if our two options are a equals 6 and a equals -6, we can reject this -6 because, again, a has to be positive. We already found b is 9, so we don't have to worry about that part. But that means that a is 6. All right, that's not our answer, though, because they're asking here, it says, what is the value of AB? So if A is 6 and B is 9, we would write A times B is equal to 6 times 9, which equals 54. All right, so 54 is the product of A and B, which is option C. So that's how you do that one. And for all the people who are saying, no, you should use Desmos for everything, the reason they're asking what's the value of A times B is that you can't just plug these values in Desmos and figure out which one works. I know there's things that you could do with sliders and playing around with it, but you know, at the end of the day, it's probably just better to learn how to do the algebra. You know, if you have a clever solution, that's fine. Just make sure it works before you go in on test day and waste too much time doing it. So the function f is defined by f of x equals a times the square root of x plus b, the square root of that entire x plus b thing, where a and b are constants. In the xy plane, the graph of y equals f of x passes through the point 24, 0, and f of 24 is less than 0. So which of the following must be true? So the options you have are f of 0 equals 24, f of 0 equals -24, a is greater than b, or a is less than b. Well, I'm going to start with this -24, 0. I'll plug that in. So when x is equal to -24, we would get our output is 0, right? The y value is the f of x. So 0 is equal to, and it's a times the square root of, instead of x, we'll do -24 plus b. All right, so we get this. And I guess you could say, you know, to get rid of the square root, we'll square everything. So square the entire right side, square the entire left side. 0 squared is still 0. So 0 equals a squared times negative 24 plus b, which tells us that either a is equal to 0 or negative 24 plus b equals 0, which is true when b is equal to positive 24. All right, so those are two options. It doesn't necessarily mean a is 0 or b is equal to 24. So these are both possible. You could test which is true with this f of 24 is less than 0. So f of 24 would be equal to a times the square root of 24 plus b, okay? And we're saying that that is less than 0. So a times the square root of 24 plus b is less than 0. So just looking at this, if a were equal to 0, then you'd get 0 times the square root of 24 plus b. It doesn't even matter what b is there. Anything times 0 is 0. So you get 0, which is not less than 0. So this would fail. So it doesn't work if a is equal to 0, which means the only other way that this was true, where you got an output of 0 when x was negative 24, is if b is equal to positive 24. And we can check if that works, right? Whatever a is, we get a times the square root of 24 plus 24. That could be less than 0 if a is negative, right? Because the square root of 24 plus 24, that would just be the square root of 48, which is, what is that, 16 times 3, so it'd be 4 root 3. So a times 4 root 3 is 4a root 3 is less than 0, which if you divide both sides by 4 root 3, that just tells you a is less than 0. All right, so a is less than 0, and b is equal to 24. Those are the two things that we know here. And f of 0 equals 24. I don't think that's true. You know, I would inputting 0, you'd get negative 24 plus 0 squared. It would just be an imaginary solution. It's not that. F of 0 equals negative 24. No. A is greater than b. Oh, actually, the other thing with these is like it would have to be either c or d because those are opposites unless a equals b, which I mean is possible, but you know, if you get something like this where they're just trying to invert it, right? You can't just, if you input negative 24 and get an output of 0, that doesn't mean if you input 0, you get an output of negative 24 or positive 24 or something like that. Like it could be a coincidence, but it's likely not that. It's likely going to be one of these two things that are basically opposites, just without the equals b part. All right, so we said a is less than 0, b is 24, so b is the bigger of the two. So if you want to think the alligator method, the alligator is going towards the b is bigger, so b is greater than a, or in other words, a is less than b. All right, so that would be option D. All right, here we have a table. We have our inputs and our outputs. Our inputs as x's, which could be 21, 23, 25. Our outputs are y's. We get negative 8, 8, and negative 8 respectively. All right, so the table shows 3 values of x and their corresponding values of y, where y equals f of x plus 4, and f is a quadratic function. Okay, so if we wanted, we could even write what f of x is here. And we're just adding 4 to f of x to get y. So that means f of x is always 4 less than y. So 4 less than negative 8 would be negative 12. 4 less than 8 would be 4. 4 less than negative 8 would be negative 12. All right, so they said it's a quadratic function, which I was already kind of assuming based on the fact that we had 2 inputs with the same output. And that's telling us when you had an input of 21 and when you had an input of 25, they both had an output of negative 8, which means the axis of symmetry is halfway between those. So the axis of symmetry is at x equals 23. So the vertex of this y, right, y equals this, so y equals f of x plus 4, is at x equals 23. So 23 comma 8 for this one, it's a negative parabola, right? We had, what is this, 21 comma negative 8, 25 comma negative 8, and this would be 23 comma positive 8. Like that, that's y. And again, the f function is just 4 lower than that. So instead of at 8, it's going to be at 4. And then these 2 points, instead of at negative 8, would be at negative 12. So 21 comma negative 12, 25 comma negative 12, and this would be 23 comma 4 as your vertex. All right, this is f of x. All right, so I didn't even read what they're asking for yet, but that would be where I'd be starting with this one. So it says, what is the y-coordinate of the y-intercept of the graph of y equals f of x in the xy plane? All right, well, the y-intercept is going to be way over here. It's where it crosses the x equals 0 line, or the y-axis. So what I would do for this one, using these points that we have, that I just drew, the pink ones, I would figure out what the function f of x is equal to. And don't get thrown off by the y equals f of x part. Like this was just, it's saying that the table represents y equals f of x plus 4. You could say essentially like this could be g of x, and then you'd write g of x there or whatever. This y does not correspond to the y on the table. Okay, but we're using this pink function, and our vertex, our h comma k, is at 23 comma 4. It's this point. It's this point in the middle just shifted down by 4. So if we were writing out our quadratic in vertex form, that's y equals a times the quantity x minus h squared plus k. We could plug in our h comma k and we'd get y equals a times the quantity x minus 23, at our h value, 23, squared plus 4. Okay. Now, the only thing that we need to figure out besides that is the a value. And what I would do for the a value is I would go, okay, well, generally, for one, we know it's negative. Right? We know it's negative because it's going down from the vertex. So if you have a maximum point and then it's going down to the left, down to the right, that means the negative quadratic. So our a value is negative, and generally you go over 1, up 1 squared, or if it's negative, then it would be over 1, down 1 squared, which is down 1. So over 1, down 1, over 2, down 2 squared, or up 2 squared, in this case down. So that's down 4. And let's see, went from 4 to negative 12. That's not down 4, that's down 8. So comparing it to just the standard function, it's going down twice as fast. We don't even need these points at x equals 22, x equals 24 to figure that out. Just, it's a quadratic. They told us it's quadratic. So just for this one, it should be over 2, down 4, over 2, down 4, but instead it's over 2, down 8, over 2, down 8. So that means that our a value is negative 2. The negative we knew because it's a negative quadratic. It's a frown. The 2 because it's going down twice as fast. So we get y equals negative 2 times, again, we have x minus 23 squared plus 4. All right, so now if you want to find your y-intercept, you could multiply this out and then just figure out what your c value is when you write it in standard form. So ax squared plus bx plus c, because the y-intercept is when x equals 0, so the x squared term, the bx term don't matter. You're multiplying by 0. All you have left is the c term. The c is not this plus 4. The plus 4 has to do with the vertex. But what I would do on this one, and honestly, maybe after I do it in Desmos, I will show that you could do it mathematically. It doesn't take that long. But really, there's no reason not to do this one in Desmos. It's just so much easier. So I would just type it in. First, get your function correct. And actually, once you do it in Desmos, you could also check that you did it right. So we'd go, okay, y equals negative 2 times the quantity x minus our h was 23. And make sure you square it. Plus our k value was 4. All right, so we get 23 comma 4. And then if we look, what were the other points they gave us? 21. We can check our other values. It was like y equals negative 12. No? It was y equals negative 8, right? We get, no? Oh, okay. Well, good thing I did it on Desmos, because otherwise I would have got it wrong. So this is not going down 8, right? It's not going from negative 4 to negative 12. It's going from positive 4 to negative 12. So it's actually going down by 16, right? When x goes over 2, it goes down 16. So a value is not negative 2. Our a value would be, let's see, it's supposed to be going down 4, and you're going down 4 times more than that. Right? You're going down 16. So our a value is actually negative 4. Still negative because it's a frown, but negative 4. All right, so that's a good catch, because I could have done all that math, and then I would have just assumed that was right. But the Desmos has this built-in check. So we would type y equals negative 4 times the quantity x minus 23 squared plus 4. Still have our vertex at 23 comma 4. And when our y value is equal to negative 12, we could see, right, we have 21 comma negative 12, 25 comma negative 12. All right, so those are our two things. I guess if you wanted to type in the original If you wanted to see if it's the original function, you would just basically shift it up 4 more than that. So you would do y equals -4 times the quantity x minus 23 squared. Instead of +4, you do +8. This was our original function, 23 comma 8, and it passes through these points, 21 comma -8, 25 comma -8. Right, so you can see that was the original function, then we shifted it down by 4, shifted it down by 4, and shifted all these points down by 4, okay? So we got those, and again, they're asking for the y-intercept. So the y-intercept is when x is equal to 0, and you can see it's really far down here, oh my gosh. It's actually kind of very hard to see where these two cross. I guess if I play with the settings here. Like that. So I guess what you could do, so that was looking like it was really hard to find where those two cross, but what you could do is just set the x-axis so it's changing by a very small margin, whereas the y is it's like this huge thing from -6,500 to +3,000, and then you can just find it like that. So 0 comma -2,112. That's where x equals 0 crosses y equals -4 times the quantity x minus 23 squared plus 4. And again, that would be the actual f of x function. All right, so that would be how you do that one. I guess the trick with that one is it's such a small number, and at that point, the quadratic is so steep that it's hard to see where it actually crosses there. But, you know, like I said, if you just play with this, I clicked this little this wrench button, and then you can adjust the axes so it's a little bit more visible. So make sure you're comfortable with how to use those, how to adjust it like this so it's a little bit easier to work with. I think the next time I come back, I'll have to fix it back. Or, you know, right now I'll just change it to -10 to 10. And I'll do the same thing for the x-axis. All right, so now it's just more of a standard view. Again, that doesn't help for the ones that are on here, but just for the next problem, that'll be useful. And just to show you, if you want to do it algebraically, so I guess if you do it algebraically, you don't have to worry about messing with the axes of the Desmos or anything like that. I thought it would be a little bit simpler than that. Then you would just multiply this out. And again, we're just trying to get it into standard form. So y equals ax squared plus bx plus c. And the c value is going to be our y-intercept. Right? Again, that's not the same as the +4. So actually what you could think about with this, the c value is going to come from just the -23 squared part. Right? So you don't even have to worry about this other stuff, right? The x squared, right? It's going to end up being -4x squared. What is that? Times -23 times 2 is -46x times -4, which would be -184x. But again, that part doesn't really matter. So you don't even have to worry about multiplying that out if you could see that. It would just be the -23 squared, which would be +529 times 4. Right, so -4 times 529. The negatives will, so positive 529 times -4. So it would be negative, it's going to be -2,000 something. Let's see, 29, let's see, 30 times 4 would be 120. So we just have 4 less than that, so it would be 116. So 2,116. And then we have +4. So -2,116 plus 4 gives you -2,112. Right, that's your c value. Again, the c value is what we're looking for. So we have -4x squared minus 184x. What's that? Is equal to y. So when you set x equal to 0, that cancels, the y is equal to -2,112, which is the same thing we got when we did it graphically. I don't actually know which of these would be faster, playing with the axes or just plugging it in. I guess if you have a calculator, this actually could be faster if you have a handheld one. But either way, that gives us our answer is -2,112. This one was kind of annoying. I wouldn't necessarily say this is the hardest conceptually, because there wasn't really a point in while I was doing this where I was confused what I was supposed to be looking for. It just had a lot of steps. So, I don't know. This one's kind of a pain. I guess there's probably a trick if you do it as like a regression, you type in the table and get the quadratic that fits for that, but then you have to remember to shift it down by 4. At this part, they're really trying to trip you up. So this one, compared to some of these previous questions, like it's definitely fitting that this one's in the hard section, but it was probably one of the harder ones to do in terms of just the amount of time it takes to do if you haven't seen a problem like it before and you don't know what you're doing. All these problems, you might look at it and say, oh, he spent like 10 minutes or 15 minutes explaining this one. But a lot of times I'm explaining either multiple ways to solve the same problem or how to check your answer, or just explaining what I'm doing. So if you know what you're doing yourself, you don't have to actually put it into words. You just would understand it, so you can just do it. Or, I mean, I don't generally like for people to just memorize the steps, but if you know what steps you have to do, then you just go right to the work. Right? There wasn't that much actual math to do here if you look at it. Like I knew I'd draw some diagrams and stuff, but you wouldn't have to make it super detailed. Just, make sure that you're checking for your mistakes while you work. You saw that I made that mistake where I thought that the a value was -2. It was actually -4 because I thought this said -4 to -12, which would be a change of 8, but it's actually 4 to -12 is a change of 16. All right, here we have, let's see, that's question 59. So we have 8 questions to go in this video. A quadratic function models the height in feet. So the height in feet of an object above the ground in terms of the time in seconds after the object is launched off an elevated surface. All right, so it's not starting from the ground, it's starting at this elevated surface. It's going to follow some kind of projectile motion like that. The model indicates the object has an initial height of 10 feet above the ground. So this is 10 feet here, and reaches a maximum height of 1,034 feet. So this is really not drawn to scale here, but all right, it goes up to 1,034 feet. And that's 8 seconds after it's launched. So if this was time 0, it hits that at 8, 1034. Based on the model, what is the height in feet of the object above the ground 10 seconds after being launched? And it is quadratic. For a second, I was like, hopefully this is not some weird zero gravity environment. This is supposed to be exponential because you're multiplying, because you're adding 1024 to it, which is a power of 2. Although that wouldn't matter if it's, you're adding it. Okay. So based on the model, what is the height in feet of the object above the ground 10 seconds after being launched? So we know that it reaches the maximum height 8 seconds after, so it's going to be going down after that. Right? So it's going down for 2 more seconds. We're trying to figure out it's 10, what? Right, we're trying to figure out this point. Okay, so for this one, what I would start with, let's see, you write it in standard form, your c value is 10. Okay, so your c value would be 10. That'd be if it's ax squared plus bx plus c, our c is 10 here. And we also know if you write it in vertex form, our vertex, and vertex form is y equals a times x minus h squared plus k. Our h comma k value is this 8 comma 1034. So we could write that as y equals a times x minus 8 squared plus 1034. Now, I guess the trick here, if we want to do the same thing I did in the previous one where we're trying to figure out the a value, for one, we know the a value is going to be negative because it is projectile motion, right? The a value is representing essentially like the 1/2 of the acceleration due to gravity, which is acceleration of gravity is always pulling you downward. So if we're relating it to the height, then it will be negative. Right? Generally in physics, it would be negative 4.905, or if you're doing it in meters per second, or in this case, it's feet. So that'd be, I think it's 32 feet per second is acceleration due to gravity. So it'd be half of that, so negative 16. But either way, like you can even see, it's a frowny face, like that. So the a value is going to be negative. But we could figure out how much it changed. So when you went over 8, so 8 to the left, normally you'd expect that to go down 64 if it was just -1 as your a value. But instead of going down 64, it's going down 1024. So you could think right, because it went 1034 to 10. Okay, or technically, I'm talking working backwards in time. It went up from 10 to 1034 in that time. So it went over 8, how much did the y change? The way you usually want to count it is from the vertex. Right? So it's moving 8 from the vertex, and then it moved down 1024. So think about what do you have to multiply 64 by to get 1024. So 64 times a is equal to negative 1024. And you could just divide both sides by 64, which you could do with a calculator, but I know 64 is 2 to the 6th power. So 2 to the 6th times a is equal to negative 2 to the 10th is 1024. So if we do divide both sides by 64, that'd be dividing it by 2 to the 6th. So we get that a is equal to, it still is negative because it's positive divided by, or negative divided by a positive. And then 2 to the 10th divided by 2 to the 6th is 2 to the 4th. So we get negative 16. So our a value is negative 16. Okay. So I just did that from these points. We get y equals negative 16 times x minus 8 squared, or the quantity x minus 8 squared, plus 1034. All right, and we're trying to figure out we're not trying to figure out what the a value is. We're trying to figure out what's the height after 10 seconds after being launched. So basically, we could also write this as f of x, or maybe h of x for height. So what's the height of x when x is equal to 10? You can also figure out, using what we just did, you could say, okay, well, instead of moving over 2 down 4, it's going to be over 2 up 4, be over 2 up 4 times negative 16. So down 64 from this. You can figure it out that way. 1034 minus 64 would give you, 970, which should be the same answer, assuming that I just did that math right in my head. But we also just plug it in. So we do h of 10, which is equal to negative 16 times, instead of x minus 8, it's 10 minus 8 squared plus 1034. And 10 minus 8 is equal to 2. So we get negative 16 times 2 squared plus 1034. So negative 16 times 4 plus 1034. As I said, right, it's moving over 2. So you're going down a times 2 squared, which is down 64. So subtract 34. So let's see, 34, you have to subtract to get to 1,000, and then another 30 to get you to 970. All right, so 970 is your answer there. I'll show you could also do that on Desmos. I mean, you still have to figure out what the equation is first. And I guess you can use sliders and things like that, or even a regression potentially. But, I think it is helpful to figure out what is vertex form. If you didn't feel comfortable with the moving it this way, you could also have done something using this like standard form, knowing that the y-intercept is 10. But I think it's easier if you could just conceptualize in your head, how does the a value affect how you move from the vertex or from the axis of symmetry and the y-axis as well. But all right, if we took this function that I wrote out, so it was negative 16 times x minus 8 squared plus 1034. It gives you this massive parabola like that. And let me mess with this. So I'll say the x-axis just goes from 0 to, let's do 15, like that. All right. See, it did launch from 0, 10, not from the ground. It reaches this max at 8, 1034. So that does check out. I guess what I just noticed is they did use negative 16. So that's it's 32 feet per second squared is the acceleration due to gravity in feet. So they did half of that. So I guess if someone just knew physics well enough and trusted that the SAT set this up, it didn't say it was on Earth or anything. So technically they could have done on some other planet or some moon or something where the acceleration due to gravity is different. But it seems like they like to actually do the right number. I think there was a different problem maybe in the first set of advanced math problems where they tried to do it correct, but they used negative 16 on that as well. But they said in the problem it was meters per second, or right, how many meters does it move? So they actually messed up because that should have been at least negative 4.9, if not negative 4.905 or something like that. But I don't know. That could be a little trick, is if you're rushing and you don't have enough time, just check, does it look like it might be 16? Because they probably did negative 16 for the a value for a projectile motion question. But anyway, so we have this. I guess, what did they want to find? They wanted to find when x is equal to 10. So you just write x equals 10, and then write 10, 970. So we still did have to figure out the equation. And again, if you trust that they're using the a value of negative 16, I guess you could plug it straight in like that, and then just check, oh, it does pass through those 2 points. So yeah, that's right. And if it doesn't work out, then I just showed you how you can figure out what the a value is supposed to be. Just make sure that you do have it as a negative value. So 10, 970, they said, what's the height at 10 seconds? So at 10 seconds, input of 10, your height would be 970. So same thing we got doing it by hand. Oh, and they had these all, I didn't even realize there was multiple choice, but that would be 970. But that would be C. All right, we're over 2/3 of the way done with this video. So this function f is defined by f of x equals the quantity x plus 6 times the quantity x plus 5 times the quantity x plus 1. Function g is defined by g of x equals f of x minus 1. So you're just inputting x minus 1 to the f function. The graph of g of x in the xy plane has x-intercepts at a, 0, b, 0, and c, 0, where a, b, and c are distinct constants. What is a of a plus b plus c? All right. This one, the other ones that have you solve for a plus b or a plus b plus c in this set so far, or in this set in the most recent one, were more complicated than what I think this is going to be. Because all we're doing here is we would say, okay, g of x is equal to f of x plus 1, which is going to be just inputting x minus 1. So you're just inputting x minus 1 for x in this f of x function. So into there, into there, into there. All right, so we'll just make these brackets here so we can write them all out. And I'll start by putting in x minus 1 in place of the x's. So x minus 1, x minus 1, x minus 1. This first one would be x minus 1 plus 6. The next brackets, or the next parentheses, would be x minus 1 plus 5. And this last one, the x plus 1, is x minus 1 plus 1. So now I just simplify these, right? Negative 1 plus 6 would give you x plus 5. Negative 1 plus 5 would give you x plus 4. And then negative 1 plus 1 would be 0, so it's just going to be x plus 0 just times x. Okay, so this is g of x. Right. All you had to do was plug in x minus 1 for x in the f of x function. So the graph of y equals g of x in the xy plane has x-intercepts. So x-intercepts are your zeros. Where does it cross? Where's the g of x value, the output, equal to 0? So we could just say 0 is equal to the stuff we just wrote out. So x plus 5, or the quantity x plus 5 times the quantity x plus 4 times x. And now, right, it's in factored form already. We're just figuring out what are the zeros. It would be when any of these factors, the x plus 5, the x plus 4, or the x, is equal to 0. Because you're multiplying three numbers, their product is 0. The only way you multiply numbers and get a product of 0 is if one of those numbers is 0. So x plus 5 equals 0 when x equals negative 5. That's one of your answers. Then we've got x plus 4 equals 0 when x equals negative 4. And when is x equal to 0? I mean, when x is 0. Whenever you have something like this at front, like that is one of your zeros as well. So a, b, and c, it doesn't matter which one is a, which one is b, and which one is c. You're adding them all up together. But they're negative 5, negative 4, and 0. If we add those up, negative 5 plus negative 4 plus 0, negative 5 plus negative 4 is negative 9. Adding 0 doesn't change the value. So negative 9 is the sum. That would be b. Right, so that's all you have to do here. This one, again, probably could have been in the medium section, but I guess they're just hoping that this f of x minus 1 thing trips some people up. But it's really not that complicated. A submersible device is used for ocean research. The function g of x equals negative 1/55 or negative 1 over 55 times the quantity x plus 19 times the quantity x minus 35 gives the depth below the surface of the ocean in meters of the submersible device x minutes after collecting a sample where x is greater than 0. Right? You can't move negative time. And let's see, it's in factored form. So we can figure out the zeros pretty easily. That also means we're going to be able to figure out the axis of symmetry if we need to. And our a value is negative 1 over 55. So it says how many minutes after collecting the sample, so that's x minutes after collecting the sample. So it's like what value of x did it take for the submersible device to reach the surface of the ocean? Interesting. So I thought they were going to ask for it to reach its minimum or its maximum. In this case, it would be maximum because it's a negative parabola. But I don't necessarily know that that would be the vertex. Right? I mean, it probably will be, but it technically could go above the surface of the ocean, or it could be like it never does, although that wouldn't really work for this. So that could be the vertex, but we don't necessarily know that it is. So what we want is when is the y value equal to 0? Oh, well, I'm dumb. All right, well, my first thought was they're going to ask for what's the vertex. And, I guess that could make sense for the problem is, maybe if it's like you're starting down here, you're going up and then back down, something like that. But we're trying to figure out when does it reach the surface, which the surface means it's 0 feet below the surface of the ocean. Right? Because the output of this function, the g of x value, is the depth below the surface. So we want to figure out when that is 0. So in other words, we're finding the zeros of this function, and we just want the positive 0 because it says x is greater than 0. So we'd set 0 is equal to negative 155 times the quantity x plus 19 times the quantity x minus 35. Now, of these terms, the only one that's going to matter is this x minus 35 because x plus 19 is equal to 0 when x equals negative 19. We have to reject that one because x can't be less than 0. And then negative 1 over 55 is never equal to 0. So the only one of these that could help, like when you multiply the numbers and get a product of 0, and one of the factors has to be 0, the only factor that could be equal to 0 for this problem is x minus 35. So x minus 35 equals 0 when x equals 35. So that's 35 seconds after. And so all we're doing here is finding the zeros. I guess the tricky part with this one is just interpreting what are they looking for. Because I think if they gave you this function, they say, what are the zeros? Then someone would just be able to go, okay, well, the zeros are when one of the factors is equal to 0. Let's figure that out. Or if they say, what's the positive 0 of this function? But they put it in this context. They're making it seem like they might be asking for the vertex, something like that. But that's all you have to do here. And I'll show you how to just type this into Desmos. I mean, you just type it in exactly as it is. Make sure that you type it in correctly and put the parentheses in the right spot. And you could get the same answer. So we get y equals negative 1 over 55. It's times the quantity x plus 19 times the quantity x minus 35. Now I just need to fix my, now I just need to adjust my things again. So this should be, let's do like negative, I guess we don't want it to be negative. So like 0 to, so you can also just click the home button. It brings it to like negative 10 to 10 for both of the directions. We can see, right, our vertex is there. We don't care about the vertex though. We care about when does it reach 0 for its depth. That's at 35 seconds. The other one over here, negative 19 seconds, where you're not going backwards in time. So it's going to be 35. Yeah, the negative 19, I guess that would tell you that would be how long it took them to collect the samples from when they initially went underwater, assuming that it was following that function the whole time. Although the fact that it says x greater than 0 indicates the function only applies to the time from when they collected it, just time 0. And it looks like they stayed down for a while, or like they went deeper down after they collected the sample and then they went back up. Right? They were at this depth when they found the sample, when they collected the sample, that they went down a little bit further and then they went back up. Right? And they got back up at 35 seconds. All right, so this is one that I definitely would recommend at least typing it into Desmos, even if you solved it without using Desmos, just to check your answers, and it maybe helps you visualize it a little bit better and you'll feel more confident in your answer. Right, but 35 will be your answer. Again, just always check how many minutes after collecting, and it was minutes. Right? Make sure it's not saying something in hours or seconds. They don't usually try to confuse you with the units, but it could be something that would come up. So the given equation defines the function f. We have f of x equals 4x squared minus 50x plus 126. It's a quadratic function. Our a value is 4, our b value is negative 50, our c value is 126. For what value of x does f of x reach its minimum? All right, well, it's a positive quadratic. We know that because our a value is positive here. Right, so it's going to look like a smiley face. And that means that the minimum is just going to be the vertex. So the vertex, we know that the vertex is the point on the parabola, the point on this graph of the quadratic function, that it passes through the axis of symmetry. And our axis of symmetry is going to be equal to negative b over 2a. So x equals negative b over 2a. And as we said, our a value is 4. Our b value is negative 50. So we just plug that in. We get x equals negative 50. Be careful, they do have a double negative there. You have to plug in the b value. They already have the negative there. And then over 2 times a, that's over 2 times 4. and negative 50 becomes positive 50. So 50 over 8, or I guess you could have even divided it by 2 before you're doing that. And then, divide both of those by 2, we get 25 over 4. So what value of x? This is the value of x, 25 over 4, if you want to write that. So 25 over 4, that's a simplified fraction, right? 25 doesn't have any 2's in it. But if you do want to write it as a decimal, that would be 6 1/4, so 6.25. Right? So that'd be how you do that. This one you could also just type into decimals. This one really should not be in the hard section because you're not doing anything with it. Yeah, they really don't have much consistency with it. They have some problems that might take you a couple of minutes to do. This one you could literally just type that function in and find your minimum. Or, just do negative b over 2a, it might be faster. Or, I've talked in some of the previous videos, there are other ways you could do it as well. You could complete the square. That's definitely not worth your time for one of these on the test. Or you could, if you know calculus, set the derivative of this equal to 0 and then solve it that way. So you'd get 8x minus 50 equals 0. And then you'd solve that, you'd get the same thing, 25/4. But just to show you do it on Desmos, 4x squared minus 50x plus 126. And I think you get the minimum there, 6.25, same thing that we got when we did it algebraically. So I think the main trick would be with these, like what they would be trying to get you on when they give you it. So the thing that they were hoping that you'll mess up if you just go straight to Desmos is they probably think some people will go to the zeros. Right? They'll go, oh, they're asking for the zeros, or they might figure out the y-intercept or something like that. But, just read it carefully. What are they looking for? They're looking for the minimum. That's the minimum. Make sure you type it in correctly, then you get your answer. So honestly, this one could probably be in the easy section, especially if they know that you have Desmos. All right, we have h of x equals x cubed plus ax squared plus bx plus c. So this is a cubic function. The function h is defined above, where a, b, and c are integer constants. If the zeros of the function are -5, 6, and 7, what is the value of c? Well, we can write these out. So we could say, first of all, we know there's no term in front of the x cubed. So that kind of helps us because we know when you multiply all of the x's out, if we multiply all of the x's together, it just gives us 1x squared. Or if we multiply the 3 x's together, when you have it in factored form, it would just give you x cubed. Which, you could be like, oh, well, what if it's 1/2 x and then 2x? But you could always write that in a way where it has the x's. So we just have x, and then when would x equals -5 give you 0? When it's x plus 5. When would x equals 6 give you 0? When it's x minus 6. And then when would x equals 7 give you 0? When it's x minus 7. Right, so we could write it out like this. Right, this is all we're doing here. H of x equals this. So the main trick is knowing if you're given the zeros, what would be the factors that would provide those zeros? And then, just paying attention to the value. I would call it the a value, but we already have an a right there in front of the x squared term. But the value that is the coefficient of the x cubed term, or basically the term with the highest degree, or like the degree of the function, the highest exponent. And if it's 1, then you don't even have to worry about what that a would be. So we could just write it like this, and this is equivalent to x cubed plus ax squared plus bx plus c. Now, we know that because, if you set h of x equal to 0, then that would mean that you're multiplying these 3 things, and the product of them is 0. So you multiply 3 numbers, and your product is 0. That means one of those numbers is 0. All right, so we've got this, and then you just want to find the c value, which the c value, we could multiply this entire thing out and figure out what a, b, and c are. That's fine. But the c value is just going to be from multiplying the 5, the -6, and the -7. Because all of the other things that you multiply, you'll have at least one x term in it or an x squared term. So if we just multiply those, we get 5 times -6 times -7. -6 times -7 is positive 42, the negatives cancel. And then 42 times 5 gives us 210. Right, so 210, you could also, I guess it might have been easier to do 5 times -6 is -30. -30 times -7 is also positive 210. But either way that you multiply those 3 numbers, whether commutative property or associative property of multiplication, you get this answer, 210. So that's what you do. And yeah, that's all I would do for this one. Just make sure, do check for that x cubed term, it was like 2x cubed, that complicates it a little bit more. Then you would know that one of these has to have a 2 in front of it. You have to play around with it. Then you'd have to have like a 2 out front here. I guess, I mean, it wouldn't complicate it that much. So you just multiply 210 times 2 then. But yeah, I mean, that's all you have to do because they're asking for the C term. If they're asking for the A or the B or what's A plus B plus C, then you just multiply these all out. Start by, FOIL this one, and then distribute the X to both and the -7 to both. That would be, a little bit tedious, but ultimately it wouldn't be that complicated as long as you know how to do the distributive property with binomials. All right, here we have f of x equals the quantity x minus 2 times the quantity x plus 15. The function f is defined by the given equation. For what value of x does f of x reach its minimum? Well, the minimum is just going to be, this is a positive quadratic. We have x times x, which would be x squared. So our a value is 1, which means it's just going to be a smiley face. It's positive quadratic. And that means the minimum is our vertex. And I always check that as if, right, when they ask for the maximum or the minimum, there is no maximum for a positive quadratic. There is no minimum for a negative quadratic, unless they define the domain in a certain way, such that, it doesn't extend on forever. But, it's always just a good thing to check, and it's helping you constantly conceptualize quadratics and what they should look like. But essentially, we're trying to find, because it said, what value of x does it reach its minimum? So we're just trying to find the axis of symmetry, because the axis of symmetry will pass through the vertex, and right, it's just going to be x equals something. So we want to figure out what x equals at the vertex. Now, the fact that they put this in factored form makes it really easy, because factored form gives us the two zeros, or we could easily find the two zeros. It's when set f of x equal to 0, 0 equals the quantity x minus 2 times the quantity x plus 15. And then, you're multiplying two numbers. The product is 0, so one of those numbers is 0. So either x minus 2 is 0, which is true when x equals 2, or x plus 15 is equals 0, which is true when x equals negative 15. So those are our two zeros, 2 and negative 15. If we draw out our axes, we'd have negative 15 over here, 2 right there, and the axis of symmetry will be halfway between them. Right, so you could figure out what do you have to add to negative 15 to get 2, which would be 17. So you have to either add half of 17, or add 17 halves, which is 8.5 to negative 15, or subtract 8.5 from 2. Or we could also go negative 15 plus 2 all over 2, and that gives us, and in this case, that would give us negative 13. And if you divide it by 2 to find the midpoint of them, that would be, you just leave it as negative 13 halves, or you could say negative 6.5. Right, so either of those answers would work. Again, that was the same thing as if you subtracted, what was it, 8.5 from 2, right? 8.5, 2 minus 8.5 is negative 6.5, or add 8.5 to negative 15. Negative 15 plus 8.5 is negative 6.5. So for what value of x, we said it was x equals this. So that would be negative 13 halves is an acceptable answer. You can write it as a fraction. Or negative 6.5 is also an acceptable answer. Either of those will work. All right, we have f of x equals 9 times 4 to the x power. So this is an exponential function. Our principal value is 9. Our growth factor is 4. And x is just the exponent. Okay. So the function f is defined by the given equation. If g of x equals f of x plus 2, which of the following equations defines the function g? Okay, so all we're doing here is just plugging in x plus 2 for our x value. So we'd say g of x is equal to f of x plus 2 is, keep the 9, so 9 times 4, our growth factor stays the same, except instead of to the x power, we're raising it to the x plus 2 power. Now we can see this is not an option. That would make it too easy. That would probably be in the easy section. Although they've had some of these that could have been in the easy section, but whatever. They didn't make this one that easy. But, now you could just break this up. So just knowing your exponent rules, 4 to the x plus 2, if you're adding the exponent, you can also break that up into 4 to the x times 4 squared. Right? It's 9 times 4 to the x times 4 squared. Right? Because if they have the same base, then you can just add the exponents. So we're just doing that exponent rule in reverse. Right, and now 4 squared is 16, so we get 9 times 16, commutative property of multiplication. We can move the times 4 to the x part to after the 4 squared, so put that over here. 9 times 16 times 4 to the x. All right, so now we've got the 4 to the x term separated. And do they have one that has that? No, I think we have to actually multiply it out. Well, that's 3 times 4 times 3 times 4, so it's like 12 squares. This would be 144. So we get 144 times 4 to the x is equal to g to the x, which again was just plugging in x plus 2 for the f function that they gave us. All right, so let's see if that's an option. That is option B. So that's all you have to do there. Just make sure you're comfortable with your exponent rules. I know they don't do too many exponent rule questions on the SAT, or at least as far as I've seen. But the things that you should always know, and when in doubt, just think about it logically. So say you had, right, like m squared times m cubed. M squared means m times m, and then you're multiplying that by m cubed, which is m times m times m. So ultimately what we have is m times m times m times m times m, right? You're multiplying 5 m's together, which is what m to the 5th means. So what did you do? You added 2 and 3. It's how many total m's are you multiplying, right? Or you could do the opposite, right? If you had m to the 2 plus 3, that's the same as m to the 2 times m to the 3, right? M squared times m cubed. And so that's where that rule comes from. Same thing with like a power rule. So you had, I feel like they usually don't do, they use the m's as the exponent. So I might have confused people who memorized it, but hopefully you understand it conceptually. Don't just memorize what the rules are. Say you had x cubed, raising that to the 3rd power. Right? X cubed cubed. What that means is you have x cubed. Cubed means x cubed times itself. Or x cubed multiplied by itself 3 times. So it's x cubed times x cubed times x cubed. And now using this rule, you could just add those 3 plus 3 plus 3. So we have x to the 9th. And what we ultimately had was we had 3 sets of 3 x's. So 3 times 3 is 9. That's why you can multiply these. You don't add them. Right? So it's the power of a power rule. So, a lot of these make sense. And this one we just did it in reverse. So that would be B. And I believe that was question 65. So we have one more question in this video. And then for questions 67 through 88, you can watch the upcoming videos. So that'd be part 4 of these advanced math videos. All right, we have the functions f and g are defined by the given equations where x is greater than or equal to 0. Okay, so the given equations, they're talking about these ones down here. F of x equals 18 times the quantity 1.25 to the x plus 41. And our g of x, our g function, is 9 times the quantity 0.73 to the x. All right, so these are both exponential functions. One of them is shifted up by 41. But looks like the first function, we have a principal value of 18, which is technically not a principal value because we're shifting it up 41. But 18, and our growth factor is 1.25, which means it's going up by 25% each time x goes up by 1. Because you keep the 100% you have, then you grow 25%. And, again, shift it up 41. So it doesn't start at 18, it would start at 18 plus 41, which would be, 59. And g of x has a principal value of 9, and that is the actual principal value. There's nothing added on. And this one is decaying because it has the growth factor, or what we call the decay factor, is less than 1. It's between 0 and 1. So each time x goes up by 1, you're multiplying by 0.73, which is the same as losing 27%. It's decreasing by 27% every time x goes up by 1. All right, so that's what those two functions are. I haven't even read the question yet, but it says which of the following equations, so which of these two equations, or potentially both or neither of them, displays as a constant or coefficient the maximum value of the function it defines where x is greater than or equal to 0. So our domain is x is greater than or equal to 0. And the maximum value, okay, we just said what these were. So the maximum value, for f of x, if it's going up, right, it's a growth function. So the minimum value was 18 plus 41, which is 59. So when x is equal to 0, right, so the minimum value only because of this thing is greater than or equal to 0, but I said the principal value because it's when x is equal to 0, it starts at 59, but then it's growing from there, right? It's going up 25% every time x goes up by 1. So it just grows infinitely, and it doesn't have a restriction in the other part of the domain. But either way, 59 is not even represented on there, which would be the minimum. They're asking about the maximum value. So it's definitely not 1, right? 1 doesn't even have a maximum, even with this domain. Now for this other one, let's see, it's starting at 9, right? It's starting at 9 and it's decreasing, and it's going to be approaching 0, right? The asymptote will be at y equals 0 because, 0.73, every time x goes up by 1, where you're raising it to a higher power, it gets closer and closer to 0. So ultimately, you're getting close to multiplying 9 by 0, but it will never become negative. So this approaches 0, but never crosses it. And if you went to the negative x values, it actually would go up infinitely, but we're cutting it off at x equals 0, right? So this is the domain of the function. It goes from 0 to infinity. So with this domain, where it can include 0, then the maximum point is that 9. Right? That is the maximum value. It's the principal value. So 2, 9 is a coefficient here, or I guess you could consider that a constant. And that's the maximum value of the function. So 2 it is, 1 it is not. So we can cross off A, because that includes 1. We can cross off C, because it's 1 and 2. And it's not neither 1 or 2, because it is 2. Nor 1 nor 2. So it'll be B, 2. All right, so 2 includes that maximum value. A function 1, which is f of x, does not. All right, and that one you could also type those into Desmos, and you would see the same thing. Maybe drawn a little bit more accurately, but I think it would look something like how I drew it here. Right? And so that would be the next set of 22 questions. Again, I will have that part 4 coming up hopefully pretty soon, which will finish off these advanced math nonlinear functions difficult questions. And then I believe there's also nonlinear equations, and they have some other descriptors for that. So there are 50-something questions of those. So that one will probably be 2 parts, potentially 3 parts. And then we have equivalent expressions. I might have mixed those up, but I think equivalent expressions has 27 questions. So that one I could probably knock out in 1 video. I potentially will put it into 2, or I guess we could even do 3 really short videos of 9 questions. But I think I like having them in 1, just so if someone's searching it, they can look for the question IDs that way. Potentially what I would do is upload them with fewer initially. So if anyone's taking the test really soon and they have those to study, they still have the ones that I've made so far, because they kind of take a while to edit. But then I would ultimately hopefully still make one that combines it, just so you can search it a little bit easier. I might even do that with the advanced math, like make one just mega video that combines all the videos together. We'll see. But all right, just quickly, let's recap the 22 questions we did here. So there were a lot of exponential functions in this one. Like I feel like it was actually kind of balanced exponential and quadratic. I think some of the other videos were leaning more towards quadratic. That might be inaccurate. That might be more quadratics by a little bit, but exponential functions. And, just make sure you're understanding growth factor. These ones didn't have as much to do with conceptualizing growth factor as actually understanding how the functions would look. And, you can always use Desmos if you're lost with those. They had a lot of stuff with factored form here, factored form for quadratics and for cubics. So just make sure that you understand how to use factored form to find the zeros. And then if it's a quadratic, how you can use those zeros to find the axis of symmetry. It's just the midpoint of those zeros. So that will help you with a lot of these questions. Here's the other one, factored form for a cubic. And just make sure you don't get stressed. Like I used to think, I don't really remember cubics. We did that so long ago in class or whatever, if you're taking the test a while after you took that math class. But cubics aren't really that much to be stressed about, especially on the SAT. If they give you a cubic function, it probably means the math involved is not as complicated as some of the quadratics that you get, even in the hard section. Because they're anticipating people that kind of freak out when they see a cubic. Like, I don't know what this is supposed to be. Well, if they're talking about the zeros of it, then, just it's factored form. And factored form looks the same, except instead of 2 factors, you have 3 factors. Or I guess a quadratic could have 2 factors, but not that deep. And yeah, here's another one. Axis of symmetry. Make sure you know x equals negative b over 2a. That helps. This one, I guess, you could just type it in Desmos and find it really easily. I really think this one should not be 3 out of 3 difficulty, but whatever. And this one, another one that really could have been in medium or even easy. But the main thing was they're hoping that people get tripped up with the word problem context of it. But it's essentially just asking what's the positive 0 of this function that they give you, which is very easy. This one, you just plug in. Yeah, they had a couple like this where you're plugging in something x minus 1 or x plus 1 for a different function. So don't get stressed with those. Some functions you would actually have to square it. It would be a little bit annoying. But for this one, we're just doing the zeros. So I think the only thing that would trip people up is, potentially they could mess up this math if they're trying to do it by hand and just, make some careless error. And then just make sure you're comfortable with if you have either quadratic or cubic or even like a quartic function, if you have an x out front, even if it's like 2x and this, then this x is also one of the factors. So think about if you're trying to find the zeros, when is this equal to 0? When x is 0. Okay, so that's something that comes up sometimes. And, oh, I liked this one, the projectile motion question. I mean, this one, it might be a little bit annoying for people who are not comfortable with finding the A value from like a set of points. There are also some tricks that you can do with the calculator. So you run some kind of regression with that. I think I'm not going to show that. I think that's a little bit more complicated than just doing it this way. But if people really want that, put that in the comments, and I could potentially make a separate video going through how to do that. There are also some resources online showing you how to do that. And this one was doable with the calculator, but it was actually, you saw it was pretty annoying to find on the calculator. I actually think it might have been easier to just do it this way. And like I said, you didn't even need to find this negative 4x squared, the negative 184x, because all we were looking for is the C value. So just, be careful with this one. I think when I was typing it into the calculator, I had an error with something, I caught an error using the calculator. Just, be careful. Don't do all of the hard steps, but mess something up like thinking that this is negative 4 when it's actually 4. Make sure you write clearly enough that you can read your handwriting and stuff like that. This one was interesting. I didn't think it was that complicated, but I could see people getting tripped up on this. I think this might have been the first square root question that I saw on the nonlinear functions set so far, or at least one that you kind of had to do this conceptually with it. But the square root part didn't actually complicate it that much. This was more, just using the rules that they gave you and kind of thinking it through logically. And like I said, if you got to a point where you had to guess, if you have two things that are kind of opposites of each other. Now, like I said, it could have been the fact that A is equal to B. That's a possibility. But if you read the problem, you realize that's kind of unlikely and wouldn't really have anything to do with these. But you could quickly eliminate A and B. So say you didn't have time to do this problem, then at least you'd get a 50-50 shot. And, I think hopefully the way I explained it was clear. Let me know if this one's confusing, but I thought that was a fun problem. This one was just annoying because you had these fractions, but the fractions ended up working out really nicely. And just always read carefully that you need it to be positive constants. They're not looking for the value of A or B. They want the value of A times B. So take that extra second at the end. This one, you can't actually solve what they're looking for because they don't have the m-sups, but we know what they are looking for is like which one has 576 squared. They don't want it actually written as 576 squared, I'm guessing. It probably actually has that number out, but just type that in your calculator. I would have done that if they had answer choices, but they didn't. This one was an interesting question. It could have been like a medium geometry question, in my opinion, but I don't know. This didn't really use nonlinear functions so much, in my opinion. This formula for surface area is nonlinear is what they're going for, but I think this one's kind of mischaracterized, but whatever, that was doable. This one was also kind of a geometry question, but I guess this one at least had a little bit to do with nonlinear functions, but I still would have probably put this in geometry, but neither of those was too bad. This one was kind of fun. X squared plus bx plus c. Yeah, I thought this one was interesting. Let me know if you thought it was confusing how I explained it, but I think it's pretty doable. Would I use the negative b over 2a and then used one of the points, or used the midpoint of those two zeros to find that. I'm sure there are other solutions for this. If you have an interesting one, make sure to share that as well in the comments. But I thought that was a fun problem. There's another exponential one. These ones with fractional exponents, and the fractional exponents ones, it seems like, at least the ones that I've seen so far, are not that complicated. And actually, they make the numbers work out really nicely. They're just trying to make them seem scary. So just make sure that you've done those before you go in, so you don't panic on the day of the test. And I don't think they're gonna give you any curveballs with those. But let's see, decreased by 80%. Just make sure it says decreased by 80%. You're multiplying by 1 minus 80%. So you're multiplying by 20%. And this one was fine. The most annoying thing with this was it didn't work out to be a nice number. But if you use a calculator, that's easy, and you can see the math actually worked out pretty nicely if you're good with fractions. And let's see, what's this one? Yeah, this one I think I took longer to explain than you probably need on this one. Like I said, this is another one with fractional exponents, and they worked out really nicely to make this problem actually pretty easy. Just be careful. I think they're definitely trying to trick some people with this 1.04 part. So just, if it says n%, what is n? Right? Don't write 0.04 or something like that. At least they were nice that they did 1.04. So if it's the actual percent increase and not the growth factor, then you would rule that one out anyway. But just, read those carefully. This was another geometry one. This one of the geometry questions that were on here was probably the most advanced math / quadratic function oriented. but still was not that bad. And again, if you just use Desmos, then you don't even have to factor it. Not that the factoring it was that hard. Just if anyone's getting stressed looking back at this, oh, why did you do this factor tree or like the thing here? I didn't need to. I was trying to not go straight to the Desmos. And another exponential function. It seems like they like these ones where they give you two constants and you use one of the points, and they give two constants and 2 points. Use one of the points to find one of the constants, like the b, and then once you have that, you can use the other point to figure out what the first constant is. Okay, something like that. And yeah, so that was it. Here's another quadratic function. I guess there were maybe more quadratic than exponential, but this one I think was the most balanced of the sets of 22 questions we've done so far. I really liked this set. I didn't think any of the questions were so out of left field. They had some variety though still. And, some of them were very easy. Some of them were interesting geometry applications of kind of quadratics, or I don't think they had any exponentials. But yeah, if you have any questions, comment those below if you found a better solution to one. Especially I've heard a lot of people telling me, oh, you could have done this one with Desmos, something like that. Feel free to put that below. I, as a teacher, will always kind of lean towards explaining how you can actually do it algebraically, not just going straight to the shortcut. But as you've noticed, as you've probably noticed, I've started at least going through how Desmos can be used to check it, or saying at the end of the problem, this is how you could have gone straight to Desmos. But I do kind of lean away from going straight to that, especially if I think of an algebraic solution that is almost as fast, or in some cases actually faster, depending on how fast you can type into Desmos. But keep that coming, because I think a lot of students do prefer having an idea of how you could do it with Desmos, especially if they're not trusting their algebra skills, if they haven't taken algebra in a while or something. So comment those below. If you found this video helpful, make sure to subscribe so that you see more videos like this, and just to promote more videos like this in your feed and the feeds for other people who are getting ready for the exam. And if you're taking the test soon, good luck. Hopefully you're crushing your preparation, and just go in with a positive mindset. I used to always try to convince myself that when I'm taking one of these standardized tests, it's like a game. Right? They wrote questions and they intentionally put some in that are trying to trick me. And I'm just, my goal in the game is to not get tricked, right? They were trying to trick you, trying to, differentiate which people can get it and which can't. And, you just go in, like, I have all of these tools, like I know how to solve a lot of different problems. They might give me a problem I haven't seen before, but I can use the toolbox that I have and I can figure them out. And just, don't waste too much time on one problem. Pace yourself appropriately and always do the problems that you can do first, and then go back to the ones that you're not so sure about, and hopefully you'll have a lot of time if you're pacing yourself well. But again, best of luck. I will probably try to keep getting these up. I know some people are taking the exam soon, so if that's you, hopefully I'll get another video. Hopefully this one's up in time, and hopefully I get maybe 2 more videos before then. And besides that, thanks for watching, and hope to see you in the next one. All right, see ya.